Assalamualaikum, my name is Nurul Ashikin binti Manidi, and this is my OEL presentation entitled Single Phase and Three Phase Induction Machine. The induction motor is a type of AC motor that works on the principle of electromagnetic induction between the stator and rotor. The stator is the stationary part of the motor, and the rotor is the rotary part. The induction motor is also known as asynchronous motor because its rotor rotates at a speed less than the theoretical synchronous speed of the motor. The rotor of induction motor rotates due to the rotational magnetic field RMF generated by the stator winding surrounding it. The single-phase supply can generate RMF because the windings carry the same current that varies at the same time. Therefore, it requires extra starting mechanism, while three-phase supply can easily generate RMF because the winding carry the same frequency current having phase difference that generate a smooth RMF. So next is the methodology of the simulation. So here is the schematic diagram for simulation of single-phase induction machine. So as we can see here, we construct and perform this circuit using PSIM software. Then we utilize the mechanical electrical interface block at the end of motor shaft and connect to a grounded resistor as a load to the system. Then set the initial capacitor values to 400 microfarad and the input terminal voltage to 240 volt. Run the simulation and we repeat the same step by using different value of capacitor from 400 microfarad until 40 microfarad. After varying the value of capacitor, then we vary the value of input terminal voltage from 200 volt until 240 volt. While this one here is the schematic diagram for three-phase induction machine. It is not much different from single-phase induction machine, except that it uses a three-phase voltage source. However, in three-phase induction machine simulation, we only gonna vary the number of pole, which is from 4 until 12. Here are the results of simulation for single-phase induction machine. From the result, we can observe that the value of output current, output voltage, output power, speed and torque are increased in a very small value when we increase the capacitor from 40 until 400 microfarad. The only obvious difference when we increase the capacitance value from 40 microfarads until 400 microfarads is that the period to reach a steady state condition. The time taken to reach a steady state condition for 40 microfarad is almost 10 seconds, while it's almost 6 seconds for 400 microfarad capacitance. Next one here is showing the result for simulation when we vary the input terminal voltage from 200 until 240 volt. When we increase the input voltage, the output current, output voltage and output power, speed, torque also increase. When we increase the input terminal voltage, the time taken to reach a steady state condition is decreased. Next is the result for three-phase induction machine simulation. From this table of results, we can see that when we decrease the number of poles from 12 until 4, the output current is also increased. Same condition for output voltage, output power, speed and torque. All of these parameters are increasing. While from the waveform of simulation, we can see that the transient time for 4 poles is longer than for 12 poles. Conclusion for the single-phase induction machine simulation. Because the capacitor is linked in series with the auxiliary stator winding, an increase in current in auxiliary stator winding, an increase in starting torque, a decrease in main stator winding, a decrease in the starting current, and an increase in the rated torque can be observed from the presented result. An increase in input terminal voltage increases output power, speed, and torque. While for the three-phase induction machine simulation, we can conclude that when the number of poles and the number of slots increases, a large torque can be obtained and the torque pulsation also decreases. More poles mean the motor takes more power cycle to make a full revolution, as each pole represents a smaller fraction of a revolution. So that's all from me. Thank you.